25,000 miles per hour. That's how fast the Orion spacecraft will hit Earth's atmosphere when it comes back from the moon. At that speed, air doesn't just move away. It gets crushed and turns into super hot plasma, reaching about 5,000 degrees Fahrenheit. That's almost half as hot as the sun's surface. For about 6 to 8 minutes, this creates a blackout. No radio, no contact, no help. Just 4 astronauts and a heat shield that has already shown some problem. Right now, NASA is preparing for Artemis II, the first mission in over 50 years that will send humans beyond Earth's orbit. The crew: Reed Wiseman, Victor Glover, Christina Cook, Jeremy Hansen. Their goal? Go around the moon and come back safely. But there's a problem. During the Artemis I test flight, engineers found something unexpected. The heat shield didn't wear down smoothly. Instead, it cracked and chipped off in over 100 places. This problem is called spalling. Basically, heat builds up inside the shield, pressure increases, and pieces start breaking off. Not good. NASA studied this and decided something risky. They will not redesign the shield for Artemis II. Instead, they changed how the spacecraft comes back to Earth. A steeper, faster reentry. This means less time in extreme heat, but stronger G-forces on astronauts. If the shield fails, there is no backup. And danger doesn't start at landing, it starts at launch. The Space Launch System rocket produces 8.8 million pounds of thrust. When it lifts off, astronauts feel up to 3 times Earth's gravity pushing them into their seats. About 1 minute later, the rocket hits max Q. This is when air pressure is strongest, like hitting a wall of air at over 1,000 miles per hour. If anything goes wrong here, the launch abort system can pull the crew away in just seconds. After 2 minutes, boosters fall away. After a few more minutes, they reach space. Now everything gets quiet. The engines shut off, and suddenly, there is silence. For the next 24 hours, Orion stays in Earth orbit. This is like a safety check. If something is wrong, they can still come back. Then comes a big moment. Go for translunar injection. This is when they fire the engine and head toward the moon. Once they do this, there's no turning back. As they travel, they pass through the Van Allen radiation belts. These are dangerous zones filled with high-energy particles. To stay safe, the spacecraft is turned in a special way, so thicker parts block radiation. After that, they head into deep space. Communication switches to giant antennas on Earth. Then comes something intense. For about 40 minutes, when they go behind the moon, they lose all communication. No signals, no contact. They are completely alone. At their farthest point, they travel over 250,000 miles from Earth, farther than any human has ever gone. Then, they turn back. The journey home begins. Now comes the most dangerous part, re-entry. Instead of a smooth glide, Artemis II will use a steep descent. This reduces heat time, but increases pressure on the crew. As Orion hits the atmosphere, speed 25,000 miles per hour, heat 5,000 degrees Fahrenheit, G-force nearly 4 times gravity. Outside, the capsule is surrounded by fire. Inside, astronauts feel like a heavy truck is sitting on their chest. Then, blackout. No communication for about 6 minutes. This is the moment everything depends on the heat shield. If it survives, signals return. Then parachutes deploy. Small chutes stabilize the capsule. Then 3 massive main parachutes open. Each one is huge, over 100 feet wide. Speed drops from hundreds of miles per hour to just 20 miles per hour. Finally, splashdown in the Pacific Ocean. Recovery teams arrive. They check for toxic gases, then open the hatch. Fresh air rushes in. The astronauts are safe. But this mission is bigger than just survival. It proves we can go back to the moon. Next step, Artemis III. Landing humans on the moon again. And after that, maybe Mars. Those 8 minutes of fire, they're not just danger. They're the gateway to the future. The journey doesn't stop here. We're not just going back to the moon. We're learning how to stay there, and one day, those same flames of reentry might be the path all the way to Mars.